Good morning, students. Second shifting property in Laplace transform. Here we discuss second shifting property. We know the first shifting property, L of f of t is equal to f bar s. Then L of e raised to at f of t is equal to f bar s minus a. E raised to minus at f of t is equal to f bar s plus a. That is known as first shifting property. Here we discuss second shifting property. Second shifting property says that if L of f of t is equal to f bar s, Laplace transform of function f of t is equal to f bar s, then L of f of t minus a into u of t minus a. U of t minus a is a unit step function. F of t minus a into u of t minus a is equal to e raised to minus as into f bar s. We can prove the result. Proof. Laplace transform of f of t minus a into u of t minus a is equal to integral 0 to infinity f of t minus a u of t minus a into e raised to minus st dt. From the definition of the Laplace transform. From the definition of the Laplace transform, 0 to infinity f of t minus a into u of t minus a into e raised to minus st dt. Then, by the property of definite integral, we can split into 0 to infinity e raised to minus st f of t minus a. 0 to infinity can be taken as 0 to a. F of e raised to minus st f of t minus a into u of t minus a dt plus a to infinity e raised to minus st f of t minus a u of t minus a dt. By the property of definite integral, we can split the limits 0 to infinity, 0 to a to infinity. In the case 0 to a, unit step function will be 0. Therefore, first part will be 0. The second part, 0 a to infinity, e raised to minus st, the second part will be 1. From the definition of the unit step function, a to infinity, the u of t minus a is equal to 1. Therefore, e raised to minus st into f of t minus a dt. Then we can integrate this function, we get the result, Laplace transform f of t minus a into u of t minus a. Here, Laplace transform of f of t minus a into u of t minus a is equal to a to infinity e raised to minus st f of t minus a dt. To integrate this function, we take t minus a is equal to u. T minus a taken as u. Therefore, dt will be du. When we change the limit t, when we change variable t to u, the limit will be changed. Limitum anodapam change cheyunu. Appo pudhiya limit endayirikkum? Pudhiya limit when t is equal to a, u is equal to 0. When t equal to infinity, u is equal to infinity. Therefore, the new limits 0 to infinity e raised to minus s into t can be written as t is equal to u plus a. Therefore, e raised to minus s into u plus a f of t minus a f of u dt is equal to du. That is 0 to infinity e raised to minus su e raised to minus as f of u du. We can take e raised to minus as outside. E raised to minus as outside. Therefore, the balance part is 0 to infinity e raised to minus su f of u du. F of u du. Then, by the property of definite integral, integral a to b f of x dx is equal to integral a to b f of y dy. Therefore, we change the u to t. Therefore, we get e raised to minus as 0 to infinity e raised to minus st f of t dt, which replace u by t. Therefore, 0 to infinity e raised to minus st f of t dt. That is e raised to minus as into 0 to infinity e raised to minus st f of t dt. That is equal to f bar s. Therefore, Laplace transform of f of t minus a into u of t minus a is equal to e raised to minus as into f bar s. This is the another result, you should remember the result. ഈ റിസൾട്ട് നമ്മൾ ഓർത്ത് വെക്കണം. ലാപ്ലേസ് സെക്കൻഡ് ഷിഫ്റ്റിംഗ് പ്രോപ്പർട്ടി അനുസരിച്ച് ലാപ്ലേസ് ട്രാൻസ്ഫോം ഓഫ് f of t minus a into u of t minus a is equal to e raised to minus as into f bar s. അപ്പോൾ ഇത് വെച്ച് നമുക്ക് പ്രോബ്ലം ചെയ്യണമെങ്കിൽ ഫസ്റ്റ് യു ഹാവ് ടു ഐഡന്റിഫൈ ദ ഫംഗ്ഷൻ. ആ എഫ് ഓഫ് ടി എന്നുള്ള ഫംഗ്ഷൻ ഐഡന്റിഫൈ ചെയ്ത് എഫ് ഓഫ് ടിയുടെ ലാപ്ലേസ് ട്രാൻസ്ഫോം കണ്ടുപിടിക്കുക. എഫ് ഓഫ് ടിയുടെ ലാപ്ലേസ് ട്രാൻസ്ഫോം കണ്ടുപിടിക്കുക. ആ ലാപ്ലേസ് ട്രാൻസ്ഫോം കണ്ടുപിടിച്ചിട്ട് അതിനെ എന്തുകൊണ്ട് ഗുണിച്ചാൽ മതി? e raised to minus a കൊണ്ട് ഗുണിച്ചാൽ നമുക്ക് ഇതിന്റെ ആൻസർ കിട്ടും. This is known as the second shifting property in the Laplace transform. Okay, എഴുതിയെടുത്തോളൂ.